I see the presenter screen.
Right into it. So the title of this talk is, are a couple of deterministic models enough to determine forecast uncertainty? And this was part of a series we did in Western Region that was kind of a we titled it Demystifying series. And here's some of the motivation for our original motivation for this talk. And so these are excerpts from 4 different AFDs. These are from Western Region, but I did take a look at Central Region, some Central Region AFDs to see if I could find similar thought patterns, and I did. And you'll find, looking at a lot of AFDs, unfortunately, it's the top 2 that are the most common. And I'm going to kind of, go through these and then kind of go through ways that we can really leverage the full suite of guidance we have available to us in this day and age. So here, the first one. 12D GFS stays relatively dry through Tuesday, but the Euro has patchy precipitation during the entire extended forecast. Therefore, there's quite a bit of uncertainty in the extended precipitation through Wednesday. Now, this is a classic example of GFS and EC forecasting, where you look at 2 deterministic models, and if they agree, you say there's confidence in the forecast. If they don't agree, you say there's not. And this is, basically 2 deterministic models are basically never enough to determine uncertainty, even sometimes in the short range, let alone in the long range. So this is the kind of thinking that we want to get away from. Second one, GFS aims it directly at the blank. I'm protecting the guilty on this one, while the Euro and the NAM push it slightly further northward. For now, we will continue to side with the Euro or NAM output, and the current forecast reflects this. Now, this is a great example of picking the winning team. So instead of saying they disagree and we don't know what's going to happen, this is the case if they disagree, but we're just going to put all of our chips in one side and hope that we get it right. Now, one of the important things to remember on this one is that we can't confuse getting lucky with being smart. And I think that there is, humans are extremely good at biased thinking. And oftentimes we will have a confirmation bias on this one where we remember the times where we made the right pick, but we forget the times that we made the wrong pick. And that isn't, that's just the way we are. Third one, this is better. This is the kind of direction we want to go. GEPS plumes indicate the operational GFS is pretty far below the mean in terms of precipitation amounts, and went with a forecast not as dry as the GFS. So this is still subjectively hedging based on the deterministic run, but it's good that it's incorporating ensemble information in the, this is a long range forecast, so I think just looking at like day 5 or 6. So looking at GEPS plumes, so even though they're hedging with deterministic, this is definitely better because the forecast is more based on an ensemble perspective of the long range. And here the last one, this is kind of what I'm going to talk about in the rest of this presentation. And it says, by Thursday evening, deep subtropical moisture overspreads the region and NACE mean precipitable water amounts reach the 99th percentile. Now, you could replace precipitable water with actual QPF, coverage of our heights, temperatures, whatever you want. But the key here is that it's not only is it using one ensemble, but it's using multiple ensemble systems. The NACE includes both the NCEP and Canadian ensembles, but then it also puts it in a climatological context to better frame what it means for the long-range forecast. So the key part to this one is not just one ensemble, but 2 ensembles and putting it in a climatological context to better leverage the information. Hold on a sec, try to get this to advance. There we go. And so let's look at some actual numbers. How much better is an ensemble mean than a deterministic model or a control member of an ensemble? And the short answer is that ensemble mean gains us about 1 to 2 days of predictability over a deterministic model. Now, you might say, nah, that's not actually that much. And most of the gain is out in days, 6, 7, 10. And you would be right to say that. But this is one of the things that I think we want to encourage, at least that, obviously I'm speaking to you guys as, I made this presentation specifically for Western Region, of which I kind of have a better feel for how forecasters think. Now, I'm assuming this is applicable to Central Region, so apply it as you feel fit. But here at STID, we're very much encouraging Western Region offices that, using Ensemble Output, we actually have confidence to message out to day 10 in some events. You know, and it's true that ensembles don't really, the ensemble mean doesn't gain us that much in, say, days 4 and 5. But when we can turn a day 8 forecast into a day 7 forecast, or a day 10 forecast into a day 8 forecast in terms of our skill, that's definitely something that we should leverage. Especially when there's a prolonged period of high impact weather where there's going to be accumulating impacts, where, like, you know, if it stays stormy in the day 8 to 10 period, that's going to be a really big deal kind of thing. Okay, let's see. Now, but ensemble means actually still leave a lot on the table. If you think about it, an ensemble mean, you're essentially collapsing an ensemble. In the case of ERP, you're taking 50 ensemble members and you're collapsing them into essentially a single map. And that is, you're losing information that way. And that's why I want to show this plot. This plot shows basically a POP, probability of 1 millimeter per day. And it's a Brier scale score. This is from the ECMWF. And what this is essentially saying is that in ensemble mean, we lose a lot of the information, but this thing, we leverage all of the ensemble members to produce a, say, probability of exceedance or percentile forecast, so specifically probabilistic forecast. Now, instead of us gaining maybe 1 or 2 days, you can see here that if you just use a deterministic model for POP, you essentially are down to 0 skill at day 3. But if you use the ensemble, European ensemble, you actually have this skill out to day 9. And even then, the maximum skill that you get out of the deterministic model, which is about 0.2 on the Brier skill score at day 1, that's matched in the ensemble at day 5. So this is, you know, when we move from the mean approach to the actual probabilistic forecast approach, then it's night and day. There's no competition. The ensembles are just going to kick butt. And you can also see one last interesting thing is that the deterministic European model is actually better than the control run for the ensemble, probably due to its higher resolution. Okay, so how about flip-flops? This is a big question that people ask about ensembles. And you can see in this left-hand plot, it's a plot of the filled-in triangles are the ensemble mean, and then the open circles are the ensemble control, so a single run. So essentially an ensemble mean versus a single run. You can see that they've essentially created an inconsistency index, and I'll spare you the details of that, but essentially it measures how the degree to which the forecast is changing with lead time. And you can see that the deterministic model dramatically has much more dramatic swings in its skill, especially beyond day 5 than the ensemble mean does. And here on the right side plot, they've actually looked at I think it's a 6-month period, and they've looked at this inconsistency index on average over a 6-month period. And you can see here, it's quite an interesting result. So the control run is those 4 lines on top. And what you can see is that the degree to which it flip-flops relative to the ensemble mean starts to diverge dramatically at about day 4, and it keeps increasing all the way out to day, hour 360. But the ensemble mean, not only is it lower in general, even in the mid-range, but once you get out to the long range and the extremely long range past day 7, it actually plateaus in terms of its flip-floppiness. So what this is saying is that the control, the further and further out you go past days 4 or 5, it just gets worse and worse and worse in terms of its tendency to flip-flop, whereas the ensemble mean, it's a little bit worse, but then it really doesn't get any worse past day 7 in terms of, and what this means is that if you're trying to ascertain whether a major synoptic system is going to come to fruition, in the way out there, day 10, day 9, day 8, day 7, really there isn't going to be an increasing amount of inconsistency in the forecast using the ensemble mean. Okay, next slide. Another question, is it beneficial to use multiple ensemble systems? And this is a plot out of a paper written by Tom Hamill from SROL. And it's specifically detailing the post-processing methods that are used for POP in the MBM. And these are all reliability diagrams. So essentially the best forecast possible follows that dashed gray diagonal. You can see in the upper left, the raw NCEP ensemble is quite poor in terms of its Brier skill score for POP. not very reliable. The center plot in the upper row center is the Canadian, which is actually better than the raw NCEP ensemble. And then on the right-hand side in the upper plot is the combination of the two. And so what this is saying is that, you know, to answer the question of do multiple ensemble systems add value, well, it depends on where you start. If you start with the NCEP ensemble and you add the Canadian, you're going to do better with the two combined. But if you started with the Canadian and you add the NCEP, you're actually going to be doing worse than if you just use the Canadian. When we get to the lower panel, the lower row, this is where we start doing post-processing on both of these ensembles. Now, I'll spare you the details. If you want to read this paper, I encourage it. It's pretty dense. I'll spare you the details of what all of this means. But essentially, these are post-processing techniques using a precipitation analysis, graded precipitation analysis, to correct the different biases that are inherent in the ensembles. So you can see we just quantile map, all of a sudden the reliability gets much, much better than the raw ensemble. Then we use a stencil around that single point and it gets better. We dress it as well, it gets even better, and then we smooth it as well. And essentially, by the time we've done all this post-processing, we have a almost perfectly reliable forecast, and the Breyer skill score is dramatically higher than it was with either of the individual ensemble raw ensembles. So what this is saying is that multiple ensembles will add value in general, but post-processing those ensembles for many fields is really where you wring out the most value. And this is important because the MBM has significantly more post-process fields than things like superblend or cons guidance. Okay, so I've been pretty rosy so far. So are there any drawbacks to the ensemble? Like, what are the problems with this? Well, there are some. One is ensemble systems tend to have lower resolution than the companion deterministic models. So this is particularly important in complex terrain, which is the vast majority of the Western region, but then quite a bit of Central region has to deal with complex terrain as well. Interpreting ensemble output can be actually quite complicated. For instance, QPF forecast, if you have, you know, a stalled front, so in a given area, you're either going to get an inch or you're going to get nothing, and you have half your ensemble members saying an inch, half of saying 0, you know, you're going to have a mean QPF forecast of half an inch in that situation. And so it can, you know, using ensemble means and other ensemble tools can require the forecaster to have some kind of checks and balances in their mind that they don't have to worry about it. They're just using deterministic guidance. And then problem number 3, and this one isn't really inherent to ensembles, it's more inherent to our agency, is that we really do not have high quality ensemble visualization tools, at least not that are all in one place. You know, the ones that we have are kind of spread around. Some are in third-party applications, some are in GF or AWIPS, some are in, you know, web-based tools from NOAA or the National Weather Service. So our ability to analyze and visualize all of this data is quite lacking in the grand scheme of things right now. You know, different groups are working on that, but it's going to be a problem for the next few years. Okay, so having said those things, I'm going to just summarize kind of what I've talked about so far. So one, ensemble means give us a day or two of extra lead time, especially in the far long range. But more importantly, probability exceedance, percentiles, and other purely probabilistic forecasts are dramatically improved when you use ensembles. And this includes, you know, we've been doing a probabilistic forecast for a long time, which is POP. But going into the future, a lot more of our forecasts are going to need to become probabilistic, not just for the sake of our partners, but because really we're just going to be leaving too much on the table if we use ensembles to generate deterministic forecasts like we've always done. Forecast flip-flops dramatically reduced using ensembles. While putting multiple ensembles together is beneficial, post-processing adds a lot of value. And like I mentioned before, the MBM already has a gap over cons and superblend when it comes to blended multi-model, multi-ensemble guidance. And that gap's going to only widen as more and more science gets into the MBM. And for probabilistic grids that we already have, such as POP, grids that forecasting intuition might not be as strong for, like sky cover and dew point, it's actually getting more and more difficult. Now, I'm not saying that it's perfect, because there's a lot of MBM fields that need to be edited by the forecaster still, especially particularly in high impact situations, but it's getting more and more difficult to make the argument against using the MBM in some of these fields. Okay, so what are some ensemble tools? So out here in Western Region, we are very much encouraging our forecasters to start leveraging all these things. Many of them are not in AWIPs. Some of them will be, and I'll talk about that. Either are or will be. I'll talk about that as I detail some of them more. But upper left, you can see online ensemble viewing tools, tropical tidbits and weather bell. These can be very, very valuable for ascertaining, you're looking at a trough and you notice the deterministic GFS and the EC are in complete disagreement as to whether it's going to be a ridge or a trough at a given time. Looking at ensemble mean 500 millibar maps can be so valuable in this situation. Next we have the ensemble situational awareness table, which has been around for a while. This puts the GFS ensemble forecast into climatological context. How extreme is this sea level pressure maxima or minima, stuff like that. This one, people might not be as familiar with the extreme forecast index, which is in the lower left box. This is kind of like the situational awareness table, but it specifically looks at how climatologically anomalous are the ensemble surface field forecasts. And so this takes it down a level from the situational awareness table that I think can be very valuable. It's one thing to have an anomalous 500 millibar wind. 500 millibar winds never killed anybody. It's high surface wind speeds that kill people. And the extreme forecast index really helps us elucidate how climatologically anomalous the ensemble forecast is for the surface fields that we really care about. And then for the shorter range, a lot of this stuff is global ensembles, but the HREF, which includes current and time-lagged versions of a number of high-res models run by NOAA. It's a high-res multi-model ensemble, and that's a lot more for your, it's got severe winter, fire weather, a lot more of the high-res, short-range ensemble output that might not be as high quality from the global ensembles. And the HREF is available both in AWIPs and in a number of web-based tools. And then there's National Abundant Models, which is multi-ensemble post-process sensible weather. So this is, it's specifically focusing on the sensible weather that we care about and that produce impacts. Some of the fields have better science than others. Some of them are really just like an adopted super blend, but others are getting to be miles ahead of what other blended guidance provides. Okay, so here's a little bit of a case study here in the last, let's see, maybe 5 to 10 minutes that I've got. So here we go. This is from Tropical Tidbits. We've got a GFS and the EC forecast, and this is for the, I believe it was officially a bomb cyclone that happened last week, I believe. Yeah, the 11th. These plots are valid on the 11th. And so you can see that the GFS kind of has a two-headed trough over the west and central U.S., whereas the EC has a more consolidated and deeper single trough. And you might say, like, well, I'm not really sure which one I should trust in terms of how my forecast is going to pan out. And that's where the ensemble means can come in really handy. If you look at this is the GFS ensemble and the EC ensemble. Toggle back and forth, you can see that really looking at the ensemble means we can put really we can see that the EC is the more likely solution based on the ensemble output showing the more consolidated single trough solution, although the guess maybe is leaning a little bit more towards the solution that the deterministic is indicating. Now you might say, look at this and say, like, well, Matt, these ensemble mean heights, they don't give me a lot of detail. How am I going to, infer what's going to be happening in the surface? Well, that's where we go into these other tools. So look at the ensemble situational awareness table, and it's highlighting, 1 in every 10 years is not a very exceptional forecast for the situational awareness table, but it is highlighting a relatively anomalous surface low that's going to be forming over Kansas. That certainly verified. It was outside the CFSR climate by 2 days. It was that bright red color by 2 or 3 days out from the event. We can also look at the extreme forecast index I talked about earlier. What this shows is, these half circles and then full circles are indicating 95th percentile or 99th percentile forecast for either precip in the green or wind in the purple. So this is obviously highlighting, yeah, you're going to get some pretty anomalous precip over Wyoming, Colorado, northern Nebraska, southern South Dakota, and it's going to be very windy in a lot of New Mexico and some other areas. Now this was a 5-day forecast. This is what the same plot looked like on day 2. And so you can see with all of these full big circles that are purple and green, you know, it's clearly highlighting the fact that at this particular time, so this was kind of earlier in the storm, northeast Colorado, western Nebraska, we're going to be getting hammered by wind and snow, or wind and precipitation, you know, and then you can see the blue contours are indicating that it's also going to be quite anomalously cold, 95th percentile or better cold. So this is a really good plot to really elucidate what's going to be happening from the ensemble perspective. You can also see if we go down south Texas, you know, the anomalous heat is going to be coming up from the south, from Mexico, ahead of the trough, as well as the very climatologically anomalous winds over all of Mexico and New Mexico and West Texas. Okay, next plot. So this is a weather bell graphic showing the probability of 24-hour snowfall greater than 6 inches. And this again was a 5-day forecast, and it's highlighting really a lot of the places that did end up getting significant snowfall. If I put in, this is the plot from the day 2 or day 3 forecast, and you can really see that the EC Ensemble was giving a great heads up as to where the heaviest precip was going to fall, even as we were wondering where exactly the surface low was going to be and exactly where the heaviest precip was going to end up occurring. And then you can compare that with wind. This is the wind forecast from the EC Ensemble, also a weather bell probability graphic. So this is the probability of a 10-meter wind greater than 40 knots. And you can see, again, it's highlighting a lot of the areas that ended up being quite windy: eastern Colorado, central Nebraska, northwest Kansas, and then also up in the upper Midwest, like Wisconsin. One more graphic from the EC Ensemble. This was interesting. So my understanding is that Sioux Falls ended up with about 5 inches at the airport there from the storm. And I thought this was really cool. So this upper panel shows all of the snow forecasts from the EC Ensemble. Remember, this is a 14-kilometer ensemble. So, you know, it's a global ensemble, but it's getting, you know, this is like Schref resolution. And so you can see that it's quite variable. You got anything from almost nothing to, you know, 20 inches out of the storm. And this lower panel really shows that the ensemble mean comes out to be, out of all those different options, comes out to be about 7 inches-ish, almost 8 inches for the storm total. At the same time, the EC Deterministic was going nuts in Sioux Falls, you know, 16, 17 inches. And so it's the kind of thing where you were just looking at the EC Deterministic, you might have been thinking, wow, it's going to, you know, snow like crazy. Obviously, Sioux Falls was near the gradient, but if you looked at the EC Ensemble mean, you knew that there was a big chance that that forecast was going to bust and that it could be more like, you know, 5, 6, 7 inches, which ended up verifying. Okay, I'm going to talk a little bit about the blend, both some examples for this event, but I wanted to detail, you know, the blend for all of its ensemble inputs and post-processing is still largely a deterministic tool. Like most of the fields that are coming out of it right now are deterministic, just like we've always forecast. But that's going to change significantly in version 3.2, which is the currently available experimental version, which will become operational in the summer. And it will have actually 10th, 50th, 90th percentile max T and min T. It'll have a huge amount of probabilistic output for QPF, both for 6-hour and 24 hours, a ton of snow probabilities and probability of exceedance, ice, prop snow, prop freezing rain, a bunch of things. And then there's actually more that I haven't detailed here. So we're going to have a lot of data coming out of version 3.2 that's going to be probabilistic in nature. And I think this is going to be very valuable for some of our higher impact events like winter storms, heavy precipitation, stuff like that. Okay, so looking at this event, again, the Bomb Cyclone from last week and the MBM. So this is NDFT on the left, the experimental version of the blend on the right, which is pretty similar to what the current version looks like, actually. And you can see the blend was definitely going for much higher pops than NDFT was. Now, this is common. You know, you hear a lot of complaints about people thinking the MBM is you know, much too bullish on precipitation, but this is what, and that was this is a day 6 forecast. This is what the forecast looked like as of day 3. So you can see that the blend was definitely going in the right direction on day 6 because the NDFD is generally caught up to what that forecast was. But then by this point, the blend's going even more bullish with high 90s pops over, southern South Dakota, northern Nebraska, places that did end up getting significant precip during this time frame. For those of you who are skeptical of the blend's pop forecast, this is a reliability plot over all of Central Region. Blue is NDFD, purple is the blend, and you can see that the blend actually is slightly dry biased overall. And so this is for essentially the winter period from October to February of this past winter. And the blend's dry, but NDFD is way, way drier. Now there's some reasons, some like technical reasons that the MBM forecast is so dry, but suffice to say that when we think that the MBM is too wet, it is almost never the case that it is too wet. If anything, it's slightly dry biased, but it's much more reliable than NDFD or WPC or gridded MOS. And then, the blend currently has probabilistic QPF. This is the 10th percentile on the top, 90th percentile on the bottom forecast. I didn't actually look at what precipitation amounts verified for this 24-hour period here, but one of the things I wanted to mention on this, one of the reasons I brought this up is that I know that there's been some complaints about high bias QPF from the blend, especially in the mid and long range. And the version 3.2 of the blend, so what will become operational this summer, is going to be dramatic improvement on that. So I think it will very much retain its skill and its multi-ensemble ability to really hone in on what events will occur in the long range. But it's going to lose, and we've already seen this, its significant high bias in the long range, especially, and I think that high bias is especially severe in the Central Plains and stuff like that, more so than it was out west. So those of you who thought that the MBM QPF ran too high, I think you'll be really pleased with 3.2. So last thing, I think this is my last slide, second to last slide, last informative slide. MBM winds get a lot of grief, and some of it's well-deserved, but I wanted to show, so this top panel is the 6-day forecast for wind in the MBM, and these bottom 2 panels are the NDFD forecast and the MBM forecast on day 60-ish hours, so basically 3 days out. And even though the MBM frequently misses the amplitude of high-impact events, it can sometimes do a really good job, since it includes so much ensemble guidance, at really keying in on high wind events in the long range. And it did that in this event. Clearly, it wasn't quite the amplitude that verified in this 6-day forecast, but when you look down here at the day 3 forecast, the blend is really in line with the NDFD forecast, but it also lacks all of this very significant WFO boundaries that we frequently see in such events. So I know that the MBM wind forecasts are a little bit light overall, they tend to be low bias, but it can be quite valuable in the mid to long range because of its ensemble nature. Okay, so this is the last slide, just a little bit of recap. So, really neither the MBM nor the WFOs are fully prepared for true probabilistic forecasting. There's been studies that have shown that when it comes to interpreting probabilistic output, quite a few National Weather Service forecasters are actually not very confident in their ability to interpret it. So there's kind of 4 things we're going to need to do. 1, we need the ensembles. We pretty much got those. 2, we need the visualization tools. We need to work on those. 3, we need forecasters who can accurately interpret and communicate probabilistic forecasts. And that one's also, kind of I'd say some forecasters are really proficient, some are not. And the last one is that we need partners in the public who are going to be able to leverage these probabilistic forecasts. And that's something that I think that we underestimate their ability to use such data. And this has been shown in social science research. But we also, I think, play a big role in educating the public as to how these probabilistic forecasts will be able to benefit them and really help them make decisions better. So that's pretty much all I had. These are some questions for discussion that we had put in when I presented this to Western Region. I'm going to leave those in there, so I think they're really good. Questions just to ask yourself, to ask your staff, ask managers, if you're a manager, to ask the staff that you have. And so pretty much all I had. I'd be happy to take questions. Looks like I'm basically exactly on my half-hour allotment, so I'll end it there.
Great, thanks so much, Matt. Really good presentation and good questions there too you've posed, I think, for people to consider. I'm okay running just a few minutes over with maybe a couple of questions, the first of which comes from Jim Taggart, and I'm just going to go ahead and read it. He asks, what's the best way to share these images with our partners and the public for messaging purposes? For example, we have limited resources for graphics on days 4, 5, and 6 when it comes to messaging. We don't want to put out actual amounts, but the greater than 6-inch snow graphic you showed would be very useful, but it's from a website. Is that okay?
I think that parts of that forecast or parts of that question are above my pay grade, and they were more for the Bruce and Randy types. But I would say, there's kind of, part of the problem is that we're going to go through a phase where we're shoehorning this probabilistic paradigm into the old way of doing things, and it's going to get awkward sometimes. So I definitely sympathize with, I can't remember if it was Jim or, I definitely sympathize with the question. I think to start with, I think that a lot of these images, a lot of this guidance is going to really help us as forecasters to have higher confidence in a forecast. Like, it's one thing to be able to say like yay or nay on whether we think an event's going to happen, and then there's the question of how do we message it. And so I think that it's pretty clear how I would hope that forecasters wouldn't look at this and say like, well, because it's not an AWIPS, I can't use this to even help me decide whether I think this event's going to happen. I think that it can obviously help us, know whether an event's going to happen, generally what kind of, wind or snow we're talking about. But then when it comes to sending graphics out to partners, which I think is more the question, I don't have a good answer on that one, because I don't think that like I said, we don't really have the visualization tools. And I don't think it would be good for us to be sending third-party graphics out to partners in an email or anything like that. And so I think the kind of answer is we're going to have to kludge it together a little bit until the technology catches up with, our use and our leverage of probabilistic tools. And so I think that's kind of a cop-out answer probably, but I think it's going to be the kind of thing where, like a lot of things in our agency, we're going to have grassroots efforts that develop visualization tools. I know that there's some efforts at MDL and at GSD and Boulder to come up with good probabilistic visualization tools so that we will have good graphics that we can send out to partners. But I think those honestly are probably a year to 2 years, hopefully not more away from, probably that long away from having that. So in the meantime, it's kind of going to be a little bit of free for all, honestly, and I'd leave it open to other people if they have any comments.
All right, great. Thanks for that well thought out answer. I think we have another question from Milwaukee. I've unmuted your line if you're there.
Yeah, can you hear me?
Yes, we can. Go ahead.
Okay, thanks, Jeff. Hi, Matt. Great presentation. Just wanted to get your thoughts. It's kind of an offshoot of the previous question, but we did notice that all the images, or nearly all the images you showed, are from web-based platforms and from other companies that are creating these images. Are you aware of any work in AWIPS to visualize probabilistic information from the MBM, the GEFS, the NAIFS, the Euro, etc.? And especially given with the constraints with space via the SBN, what would your vision be on how we visualize these things in the future?
I'm trying to decide what, there's kind of like the personal Matt opinion, and there's kind of the Matt as an employee of Western Region STID opinion.
How about this? Avoid the third rail, and just,
well,
do what
so the future ultimately we need to have everything in the cloud where you can do the manipulation, the visualization, and the graphic production all in the cloud remotely on a computer that really is going to be outside of the AWIPS environment as we know it today. More in the reality, 2 to 3 to 5 year period, there is going to be a significant amount of MBM probabilistic data that will be going over the SBN, and it will be able to be visualized in kind of the classic sense. But I really do think that, sorry, I'm trying to remember all the different pieces of your question, but I really do think that in that kind of interim time, the 2 to 3 to 5 year time frame, where we have a lot of probabilistic output, but we don't necessarily have the infrastructure to visualize it really well, I think we're going to have to rely a lot on web-based resources to inform our forecasts. And really, the goal would be that 3 to 5 years from now, the MBM, we're not going to be producing deterministic grids. The MBM will be producing probabilistic grids that will not even, I don't even think that it will be desirable for a forecaster to edit them, if it's even possible for them to edit them. And so grid editing will be a much lower priority, and really we'll be using these web-based tools to really inform our mental model of the atmosphere, which I consider to be the most fun part of forecasting anyway. I don't know about other people. I work shifts to the Salt Lake office. Grid editing is not the fun part. The fun part to me is the mesoscale analysis, the synoptic analysis of really figuring out if a high impact event is going to happen. And really a lot of the guidance will be informing, instead of us putting information into the grids, we will be getting information out of the grids. So, I think we're going to be transitioning much more to a web-based platform before kind of like the 10-year plan of something cloud-based comes to fruition. Hopefully that was a coherent answer to some degree.
No, that's exactly what we were wanting to get your thoughts on. And as far as the future slide that's up there, I think that first bullet that's up there, I think that's you couldn't have said it any better. It's very, very true. We are not prepared for what's about to come.
All right, we're running a little bit over more than we were expecting here, but I think that's okay. Are there any other questions for Matt before we wrap up?
Hey, Jeff, this is Randy. Can I chime in?
Please do.
Excellent presentation, Matt. Much needed discussion. I'm curious, the demystifying series that you guys have done in West Region, I think, has been fantastic, and sharing this kind of information and having this kind of dialogue is critical. So I'm curious, what are your next steps out there after that you guys just finished that series? But what are you going to follow up with to keep kind of this dialogue and communication going about what we can expect with these probabilistic fields and displays and how to use them best?
Yeah, that's a good question. Well, I think that, like Andy Edmond, my boss, likes to say, science and technology are easy, people are hard. And I think, honestly, as we're moving forward from the demystifying series, a lot of it is going to be culture change. One of the biggest difficulties is actually going to be, it's kind of like pretty much everything. There's kind of the front runners. There's the people that, I'm sure there's people that listen to this presentation that are like, you're preaching in the choir, man. There's other people that might have wanted to punch their screen. And in Western Region, we have both, and we have people in the middle. And so, we really are encouraging people, it's kind of I guess it's like three-pronged. One, we're really encouraging people to explore these tools that are not in AWIPS. There's forecasters that are very much in, if it's not in AWIPS, I can't use it and it can't benefit my forecast, which I think is not true. I think that we need to really pursue the visualization side. We're kind of pushing a few different avenues on that to try to make sure that we do give forecasters the tools that they need to utilize this stuff. And then there's that big culture change part, which is really kind of just going in and kind of demonstrating how this process works to forecasters. Again, hopefully that was not just a rambling answer.
Great, I appreciate that, Matt. So true.
All right, I don't see any more questions at this point. I think it's probably as good a time as any to go ahead and wrap up. Mac, thank you so much for joining us. We really appreciate the time you took to present this.
Yeah, my pleasure.
Great. Thanks to everybody who joined the presentations, and if there's any presenters left, thanks again for that. We definitely appreciate it. We have 5 more talks scheduled for tomorrow, starting at 10 a.m. Central. Thanks again, everybody. Talk to you later.